Good day, everyone. I am Lawal Adetunji, your physics tutor. Yes, this day today, I want to teach us scalar and vector quantity. And this one will be introduction to vector quantity because we'll be having a discussion on vector, like 3 or 4 discussion will come up on vectors. But let's start, as I said, scalar quantity and vector quantity. What is scalar quantity? When you talk about the scalar quantity, you are talking about the quantity that has only magnitude but no direction. When I say only magnitude but no direction, what do I mean? Or what's mean of magnitude? When you talk about magnitude, you're talking like value, you talk about size. So take an instance, that's why you can see in front of me here, I have voltmeter, it will read, but there's no direction. I have ammeter here, it will read, there's no direction. Same thing goes to our thermometer. Our thermometer is also reading, but no direction, telling you that temperature is a good example of scalar. Potential difference or your voltmeter also measures the scalar quantity. Your current, which is the ammeter, is also what? Is also a scalar quantity. Before I go to vector, I put on my board to let you know, because I want to also use the medium to talk about dimension of quantity. So I want to put them together so that we'll see how they go together. As I said, examples of scalar quantities and their units. I mentioned the first unit I mentioned, the first quantity I mentioned here as scalar, I mentioned distance. And you want to ask what is the dimension of distance? Remember, distance is a family of lengths. Since the family of lengths, what do you expect? The dimension of length is L. So then the dimension of distance is capital L, and the unit is meters. Now the abbreviation M, meters. For speed, remember speed is distance over time. That is L per T. L T raised to power minus 1, while the unit will be meter per seconds, or you say meter seconds raised to power minus 1. That is indices. And the next one I'm talking about here is mass. The dimension of mass is capital M, so definitely I will have my capital M, and the unit is kilogram. For volume, when we talk about volume, take an instance, the volume of cubeboard. The formula, that is length times breadth times height. Remember, length, breadth, height, their dimension is still L for each of them. So definitely I will be having L times L times L, which will give us L cube. Dimension of volume is L cube. Definitely the unit will be meter cube. For time, time also is a scalar quantity. It's reading but no direction. And the time dimension is capital T, and the unit is seconds, small x. Density is also a scalar quantity. The formula for density is mass over volume. Mass is M. Volume is L raised to power 3. So we have N, L raised to power 3, and the unit will be kilogram, meter raised to power minus 3. Temperature, I've shown to us there. Temperature is also a scalar quantity, and we can use theta. We have our common theta at its own dimension, and the unit can be degrees Celsius or Kelvin. While energy, in case you don't know, energy is also a scalar quantity, and energy formula from, we can say, if it is kinetic energy, half mv squared, potential energy, mgh. If you are referring to it as Waec, so we say force times distance. So if I'm going like that without wasting of time, my force, if I'm going from the angle of force times distance, so my force is L T raised to power minus 2, that is kilogram, which is mass times acceleration, and the distance here is L. I'll be having ml squared T raised to power minus 2, while it is unit of energy is joules, or if I want to put it further, you can say Newton, meter, and so on. So let me pick the common one, which is joule. And I put a notice to let you know when you talk about scalar, you talk about magnitude, you are talking about value, you are talking about size. That's why I'm making an example like distance. Distance has no specific direction. Where are you going to? I'm going, when you can't define the particular direction you are going to, we are talking about distance. So 25 centimeter, 12 kilometer, that's talking about distance. While speed, 12 meter per second, 5 meter per second, that's talking about speed. So that one ends the scalar, I move to vector quantity. When you talk about vector, opposite of scalar is vector. So definitely vector will be the quantities that have both magnitude and the direction. And a good example is displacement. After displacement, I'll be having velocity, momentum, acceleration, and force, and so on. Same way I want to bring out the dimension. For the displacement, the value of length, I will have L, and the unit is also meter. For velocity, that is meter, that is L, t raised to power minus 1, that is meter per seconds. Dimension for momentum, momentum is mass, that is M for mass. Velocity is L, t raised to power minus 1, and the unit becomes kilograms, meter per seconds. For force, thank God I've done force here the right time. Force is mass times acceleration, so I'll be having M L t raised to power minus 2. Remember that force is a vector quantity. How can we describe that one? Remember we have downward force, we have upward force. Force can be moving forward, maybe eastward or the westward, telling you that force has a direction. When force goes down, you are talking about force of gravity or weight. But when it is going up, that is upthrust. Are we there? So we still talking. We have videos on that. If you have a time that you have not been watching our video, please do well to watch our previous videos so now to learn more, and always subscribe, share, like. When I say you should share to people that want to know more like you. That's the only way you can help your community. Share, and also put your response in the comment section. You can also put your topic that you want us to do teaching on inside the comment section. As I'm rounding off, acceleration is what? Change in velocity per unit time. So definitely we are saying M, L, are we there? We are talking about acceleration, that is L, t raised to power minus 2. That's talking about the acceleration, and the unit will be what? The unit of acceleration is meter per second square. I'm not talking about the unit of force. The unit of force is Newton. All of us know Newton. That's the unit of force, Newton. And that is all. If what I have taught us is very clear, I will be expecting your response in the comment section. So, in order for me to know if what I've just taught us now is very clear to us, I want us to quickly have this question. We should try this and give me a response in this comment section. See you in the next video. Bye.